Hi class, so here's a video to help you out with problem number 15 from the online homework. So we're asked to determine the increase in the apparent weight of a dump truck here as a result of sand being poured into it. So you have sand that's coming down and being poured into the back of the truck. As a result, the truck has to apply an upward force on that sand to stop its downward motion, to bring its momentum from whatever it has the moment just before it contacts it down to zero momentum as it stops moving in the back of the truck. So what this means is, as a result, there's an equal and opposite force pushing down on the truck, and that combined with the normal weight of the truck gives it a new apparent weight that is larger than its original. And so it's this force that it is pushing up on the sand that we're trying to determine. And the way that we can do that is by looking at the impulse momentum theorem that we learned in class. So the impulse momentum theorem that we learned in class, if you remember, is the average force that's something of contact multiplied by the time during which that contact occurs is going to be equal to the change in momentum. So another way to write that is that the average force multiplied by our change in time is going to be equal to our mass times our final velocity minus our mass times our initial velocity. So I'm going to just write this again, factoring out the mass, since the mass is not changing. Well, actually, the mass in the back of the truck is changing, but the mass of a given portion of the sand does not change as a result of the impact. So we have mass multiplied by final velocity minus initial velocity. So now I will divide both sides by the change in time. So we have mass divided by change in time multiplied by the final velocity minus the initial velocity equals that average force. Now the reason I wrote it like this is because we're not really given information about the exact mass of the sand at any given point, and we're also not given information about the amount of time it takes for the sand to hit the truck and slow down. But what we are given in this problem statement is actually a mass flow rate, a rate at which mass is being distributed onto the back of the truck. So it's a mass per unit time, as the problem gives us. You know, your mass per unit time that you're given in the problem statement might be something like 30 kilograms per second. That's the rate at which sand is going to be impacting the back of the truck. Well, if you look here, guess what? We have rearranged this equation to have the mass flow rate in the equation itself. So if you want to find the average force, which hopefully you do if you want the green box of joy, if you want to solve for the average force, then you can take your mass flow rate here and multiply it by the change in velocity. As a hint, I'll give you the final velocity as a result of this impact is going to be 0 meters per second. The sand will come to rest on the back of the truck, and so it's up to you now to find this initial velocity and use the mass flow rate that you're given in order to solve for the average force. And once you do, hopefully you'll get the green box of joy. Alright, let me know if you have any questions, and I hope this helps.